Hey everybody, welcome to Bill Sky, the C++ guy, and in this video, this is my first advanced C++ video. Now for some of these, this may not be advanced because what we're going to be talking about in this video are pointers. Now why do I call this advanced C++? Well, in my experience at community colleges, not so much universities, but community colleges, is if I taught pointers during a first semester C++ class, I would be able to feel the wind as students rushed out of the room as soon as I started talking about it. So I'm assuming that you have the knowledge of variables, what memory is all about, simple programs in C++, maybe even some advanced programs, to start and really become, to have this video very, very useful. So let's start talking about this, and what I'm going to do is I'm going to be doing this on Linux, but I'm going to be doing it under Eclipse. Now if you're doing it on Windows, on Visual Studio Code, or Xcode on a Mac, it doesn't matter. It's pretty much the same syntax, it's the same everything. This is a more advanced lecture, so I'm going to let you decide which integrated development environment you want to use. So let's get started with pointers. Now I have Linux up here and running, and I have Eclipse integrated development environment. So I'm going to go ahead and create a new project. And for those of you that have never seen this done, Eclipse is probably the #1 integrated development environment out there used by developers, especially if they're developers that are writing for multiple platforms. Now, if you're only a Windows shop, if your company only produces Windows applications, I'm sure you're using Visual Studio. If you're only creating Apple Mac applications, I'm sure you're using Swift or you're using Xcode. But we're going to use Eclipse because it's written by developers, it's open source, it's very, very versatile, and that's what I like to use. So let's go ahead and create a project. I'm going to say CPP pointers. Hello world. Make sure you pick the correct tool chain. If you're on Windows, it would be MinGW. If you're on a Mac, it would be Mac OS GCC. Click next, next, and then I'm going to go ahead and turn off release because we don't really need release right now. We're just doing some teaching and experimenting, and I'll click finish. So, and as some of you may already know, I like to have a program ending, and the reason I like that is because it tells me that the program has actually reached the last line before the program ended. And it's also nice to say, hey, program ending, have a nice day. All right. So what is a pointer? Now, if you remember when you create a variable, and I always like to create my variables at the very top because I know where to find them all before I actually do any logic. When you create a variable, in this case an integer, what's actually happening when you create this, when you execute this line of code? Well, the compiler sees it, and when the program is executing, the compiler will actually allocate, in this case, 4 bytes in memory. It will go out and find 4 bytes in memory. It'll make that memory available to your program, and the way that you get to that memory is using the variable an int. But what does that really mean down lower? I mean, what is actually happening down in the weeds? Well, again, as I said, in memory, and let me see if I can't do a little drawing here to kind of illustrate this. So you've got all of your memory here, and excuse my drawing. And what happens is when an int is allocated, it will go out and it'll allocate 4 bytes. Now, how do I know it's 4 bytes? Because an integer in C++ and in C is always 4 bytes. And I believe it's, what is it? 32-bit, I think it's like 4 billion, -4 billion to a +4 billion, and that's what can be stored in 4 bytes. Now in int, this variable right here, this is just for your program's reference. There really isn't a variable called an int. There's not a name called an int stored in memory anyplace. It's simply a way for you to easily get to that memory location. Now, if you remember, and I hope you know this already, if you don't, you might want to take some of my other look at some of my other videos. Memory is just this big, long, linear set of bytes, and each byte has an address. And the address will look like something in hexadecimal, it'll look like something, you know, F342A, you know, some strange hexadecimal number, and it's like the address in your house. So by being able to create variables with names, it makes it a whole lot easier for you than having to remember some kind of an address like this. And back when I first started programming in the mid to late 70s, we had to know addresses. We didn't necessarily always have variables, especially if we were coding in machine code. So variables are really a benefit to the programmer. So what in the world is a pointer? Well, the pointer is a variable that contains the address of a variable. It's not just a label, which an int is in this case. It's actually a variable that contains the address of that memory location. So before we actually get into that, let's count an int. And I think all of you will understand what that's doing. That's actually going out to memory that an int is referencing, grabs that data out of that memory and prints it to the console, to the standard output. However, we can also ask an int what memory it's actually referring to by putting an ampersand in front. So by putting an ampersand in front of a variable name, you're actually saying, hey, don't go out to memory and get me that data. Tell me what memory address my variable, in this case an int, is referring to. So let's go ahead and build that. And that's what the ampersand does. It's not a pointer, because a pointer contains an address. Ampersand and int simply says, oh, here's the address that an int is referring to. And I'm going to run it. The first time I run it on the Eclipse, it asks you if it's a C++ application. And here you go. So the first one printed a 0. Why did it print a 0? Because we initialized it to 0. And when we couted an int, it went out to memory, grabbed the data in that memory location, and then put it out on the console output. However, look at the second one. The second one is the address that an int is referring to. It's not really pointing to it. An int is referring to that address. So we're still not at pointers yet, but it's very important for you to know that this 0 in memory is at this address. It's kind of like your house address, right? The big number 0 is in your house, and your house has an address, and the address is what's in memory. So that's what an address is, and that's where your 0 is located. Now, if I went in here and put 999, what do you think would happen? Well, instead of printing 0, it'll print 999, but the address stays the same. Not always, but it depends upon the environment, the operating system. But in this case, Eclipse has its own little sandbox, and it keeps it within the same memory location. So the memory is the same, but the data is different. All right, so what's a pointer? A pointer is a variable that contains the address of a piece of data's location out in memory. And the way that we create a pointer is you simply say the data type asterisk. That means that it's going to be a pointer variable to an integer. And I'm going to call this an int ptr. Now, I'm not going to initialize it to anything. It wouldn't be a bad idea to initialize it to null ptr, because that's a very special initialization constant or value. It basically just puts all zeros in there. Now I'm going to go and print out, I'm going to say the pointer stuff, just so we can see it. And I'm going to say count an int ptr. Now remember, an int ptr might be a variable that's going to contain the address of a memory location, but right now it's just all zeros. And let me prove that to you. I'll save and build it and run it. And you can see, right, oh, I didn't put an end L there, but you can see that 0 there, right? Okay, so right now an int pointer contains 0. It's not pointing to anything. If you tried to access the memory at address 0, the program would probably die with what they call a segmentation fault. And the operating system would say, get the heck out of here, we don't want you here. So how do we actually put an address into an int pointer? Well, it's actually very simple. We say an int ptr equals the address of an int. Now this works because an int is an integer and int pointer is an integer pointer, the address integer pointer. So let's go ahead and now count an int ptr once again. This line right here is exactly the same as this line. So let's see what happens now. Okay, let's look at this closely. Our first line of code right here, our first cout, prints the value that an int is referring to. It's 999, right? Because we initialized it to 999 up here. The ampersand and int prints, or when we send that to cout, it prints the address that an int is referring to. You know, hey, it's that address over there, and I know the number of that location in memory. So that's what it prints out. Now, the pointer stuff, which is down here, we cout at an int ptr. Now, because we set it to null ptr, it prints 0. It's not pointing to anything. It's just initialized to null. It's initialized to all zeros. But when we said an int ptr is equal to the address that an int is referring to, it actually puts that address into an int ptr, and when we cout an int ptr, it prints that address that it contains. So the ampersand in front of a variable, you don't have that address contained anywhere. A pointer variable will contain the address. It is a variable that actually contains the address of a memory location. So what if we wanted to use this pointer to print the value at that memory location? Well, there's a thing called a dereferencing character. So I'm going to say let's dereference an int ptr. Now, to do that, we have to tell the compiler and the operating system, we don't want to print the address. We want to go to that address, grab that data, just like we did up here. We want to go to that address, grab that data, and put it somewhere. In this case, we're just going to cout it. So I'm going to cout ampersand and int ptr. I know, there's a lot of ampersands, there's a lot of asterisks. That's not an ampersand, by the way, that's an asterisk, sorry. So that is the dereferencing character. It says, I want to go to the address that is stored in an int ptr, and that asterisk says, I want to go to that address, I want to grab that data and send it to the standard console. So I'm going to go ahead and build that and run it, and you're going to see right here, so there's our cout of an int, there's our ampersand cout, or cout ampersand an int, there's our cout of an int ptr because we set it to all nulls, there's the address that is in an int ptr because we put the address of an int into an int ptr, and now by putting an asterisk in front of an int ptr, it goes out to memory, grabs that data, and prints it to the standard console. Whew, my God. Okay, what's going on here? Well, why do we do this? Because there is a lot of code out there. There's a lot of application programmers interfaces that actually need pointers. Pointers are also small. They're also very, very fast. And sometimes programming with pointers is just better. I mean, there's Atari has an old, and I can't remember off the top of my head, but Atari has their graphical, their game interface, their graphics game library available to everybody. Oh, I wish I could remember what it was, but I'll put it in the notes of the video. And all of the libraries require pointers. You can't not use a pointer. They just want to know where is the memory that you allocated to draw the zombie, and it will draw the zombie, but you need to send me the pointer, and I'll take care of that graphics displaying to the screen. So there you go. So that's basically what a pointer is. A pointer is a container that contains the address of a variable or of memory. Now, if I wanted to do a little bit of drawing here, let's go back and draw that memory that we had, and let's hope I can do a little bit better drawing. So an int is going to be stored over here, and let's see if we can get 999 in there. So an int is referring to that memory location. So what is an int pointer? Well, an int pointer is also a memory location, And when we're right here, an int pointer has zeros in it. Okay? Now that's only temporary. We only have that in there until we actually assign a value into that pointer. So now what are we going to do is that right here, this line of code right here, we say go get the address of this guy right here, get the address of that guy, and put it into an int ptr. And I don't know, let's just say that the address of that is ABC. Now the pointer variable, which is an int pointer, the pointer variable isn't really pointing to that memory location, it simply contains that memory location. When we print an int pointer, it's going to print the contents, ABC. It's going to print that to the screen because that's what it contains. However, when we print the dereference of an int pointer, what the operating system does is that it goes into an int pointer, grabs ABC, which is right here. It grabs that data in ABC and it prints it to the screen. So I hope that didn't confuse you, but that's basically what the mechanism underneath the covers of what's happening with a pointer. It's simply a variable that contains the address of another variable. Now, the next video, this Advanced C++ series, the next one is going to be how do we create new data? How do we allocate it dynamically in memory and then save that address? Well, we're going to save it in a pointer, and we're going to do that on our next video.